Hi friends, you are welcome back to another interesting question. We are asked to calculate the length of the red line segment, that is this here. We have the length of this side to be 10 units, that of this is 11 units, and this is 14. This side is assumed to be of length h. Here we observe 3 right angles. So how can we solve this? How can we calculate the length of this red line segment? Let it be V. It is very simple. We start by labeling the points. Now look at this triangle. It is a right angle triangle. We have the length of two of its sides to be 11 units and 14 units. We can use the Pythagorean theorem on it. The Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, so we let this segment be Z. Therefore, by Pythagoras, Z plus V all squared equal to 11 squared plus 14 squared. 11 squared is 121. 14 squared is 196. 121 plus 196 is 317. So Z plus V all squared equal to 317. Take the square root of both sides. Here, square root of C plus V all squared is C plus V, while here, square root of 317. Since 317 is a prime number, we let it be. So Z plus V equal to square root of 317. Keep this aside. Now come here. Look at this quadrilateral. This angle and this are right angle, and they are opposite to each other. 90 degrees plus 90 degrees is 180 degrees. This is a property of a cyclic quadrilateral, that opposite angles are supplementary. So this quadrilateral is a cyclic quadrilateral. We draw out its cycle. Now come here. Draw a chord that will connect this point R and this. Call the point A. We take a look at this quadrilateral ARST. It also has all 4 of its vertices lying on the circumference of the cycle. That makes it a cyclic quadrilateral as well. So since this is a right angle, based on the property of a cyclic quadrilateral, that opposite angles are supplementary, this angle must also be a right angle, and since this is a right angle, this must also be a right angle. Back to this quadrilateral ARST, all 4 of its angles are right angles. That makes it one of 2, a square or a rectangle. But we know in a square, all sides are equal in length, which is not the case here, as this side not equal to this side. So therefore, the quadrilateral is a rectangle. In a rectangle, opposite sides are equal in length. That is, this side and this are equal in length, and this are also congruent. So since this is 11 units, this must also be 11 units, and since this is 10 units, this must also be 10. Look at this side PS. Its length is 14 units, and we have this segment of it to be 10 units. Therefore, this must be 14 minus 10, which is 4 units. Now with respect to the cycle, this line PS is a secant, and this line PT also a secant. They both meet at this point, so we can say they were drawn from the same external point. From the circle theory, there is a rule that when 2 seconds are drawn to a circle from the same external point, the product of the length of 1 second and its external segment equals to that of the other. So the product of the length of this line PT, which is V plus C, and this C, equal to that of the length of this second, which is 14 units, multiplied by this 4 units. So V plus C all multiplied by C equal to 14 times 4. 14 times 4 is 56. V plus C, we have it here to be square root of 317. Substitute it here. Still on this equation, we make Z the subject by taking V to the right hand side of the equation. So Z equal to square root of 317 minus V. Come here, replace this Z with square root of 317 minus V. Square root of 317 multiplied by square root of 317 minus V is square root of 317 times square root of 317 plus square root of 317 times negative V. Square root of 317 multiplied by square root of 317 is 317 plus square root of 317 times negative V is minus V roots 317. Take it to the right hand side of the equation and bring 56 to the left. 317 minus 56 is 261. So 261 equal to V root 317. Multiply both sides by square root of 317. Here square root of 317 times square root of 317 is 317. While here 261 times root 317 is 261 root 317. Divide both sides of the equation by 317. Here 317 cancels 317. So V equal to 261 root 317 all over 317. That is, the length of this straight line which we are asked to calculate is 261 root 317 all over 317. Thank you for watching. Please like, share and subscribe, and also turn on notifications. Thank you.